A 2025 study found that 95% of generative AI pilots fail in real-world environments. Usually, it's because the developers relied on the model to follow its own security instructions. Engineering teams often attempt to restrict an agent's behavior by writing system prompts, text-based rules that ask the AI to stay within certain bounds. This creates a false sense of security. Human attackers bypass these language-based rules using prompt injection or contextual manipulation. They exploit the fact that a model cannot distinguish between a developer's instruction and a user's input. This creates a structural mismatch. Security is a binary engineering problem, but a language model is a probabilistic tool designed for prediction, not strict adherence. When an unshielded LLM operates purely on text probabilities, it remains exposed to malicious prompts that can shift those probabilities in the attacker's favor. To reach production, 2026 systems are moving towards the agent harness. This framework replaces soft language rules with hard-coded architectural barriers that exist outside the model. Reliability comes from engineering a system where unauthorized behavior cannot execute, regardless of what the model thinks it should do next. This architecture relies on agent middleware, deterministic safety layers that sit between the user and the AI. These layers function like an onion, insulating the AI core so unvetted inputs never reach the internal reasoning engine. The first layer addresses context rot. As conversation histories grow, models fail to distinguish facts from noise. Chat middleware summarizes past messages into a stable structure. This also prevents the runaway loop seen in 2025, where one unguarded agent burned $47,000 in 11 days by repeating the same expensive queries. Automating the structure removes the burden from the LLM, which is historically poor at managing its own context window without making errors. By controlling what the AI remembers at a structural level, you maintain reasoning accuracy while capping runtime costs. The outer defensive layer is functional middleware. It wraps the agent's tools and APIs in a deterministic shell. Consider a scenario where a compromised agent attempts to execute an unauthorized system command or access a restricted database. Functional middleware uses strict regular expressions to detect these patterns. It blocks the command at the gateway. Because this happens at the middleware level, the threat is blocked before expensive LLM logic is invoked, keeping the cost of defense at zero. This is the architectural standard used in the Microsoft Agent Framework to secure enterprise-grade tools. Microsoft uses this ASP.NET-style architecture to catch personally identifiable information leaks by checking the data against hard-coded rules, rather than model intuition. Interception at the tool layer restricts the blast radius. If the AI brain is tricked, the structural guardrails ensure the damage cannot spread to the rest of the system. Deployment in 2026 is defined by a shift away from probabilistic guessing. Developers are prioritizing absolute deterministic control for all critical operations. This philosophy applies to the entire stack, from intercepting prompt injections to enforcing strict token budgets. To build a reliable system, you have to treat the language model as an inherently unpredictable engine that requires external containment. Every critical safety and operational rule must live in the code of the harness, not in the neural network of the model. Autonomous systems only reach scale when their guardrails are mathematically rigid. Reliability is achieved when the AI is no longer the single point of failure.